Hello everyone, I'm back. My name is Kwaku Owerudu. I am the inventor of the EGPU, which is an acronym for Energy Generation Power Unit. The Energy Generation Power Unit, or EGPU, which you're seeing here, this is an Overunity Free Energy Transformer. This is, obviously it's not a real photograph. This is a rendering of my invention, which I did in the Autocad. Okay, so I have a video. Please subscribe to my YouTube channel and also hit the notification bell. Therefore, you'll be alerted and notified every time I release a new video, which many more videos are coming. This is a work in progress. Okay. I released a video a few weeks ago. I think it's like 2.5, 3 weeks ago, something like that. But anyway, I released a video. And the title of this video on my channel is called Overunity Free Energy Transformer Full Disclosure. And so, in that video, I explain the theory and principles by which I believe this free energy device will operate. So if you want to hear my lecture in the actual principles of physics by which this device will operate, please watch that video in its entirety. Okay, so this is what the thing looks like. In this unit, it's about, it's a little over 3 feet tall. The top or front faceplate and bottom plate are 10 inches by 10 inches, 10 inches long by 10 inches wide, to give you some perspective as to the size of this device. So it's really not that big. And this device here was designed to power your average house up to 4,000, 4,500 square feet, like a house that'll have like 3 AC units, stuff like that. Okay. And sorry, I'm a little choppy in my speech. I'm not used to, I'm new to making videos and giving talks and stuff. So that's why I sound like this, just to let you know. So anyway, let's go to the next. Okay, so this is a cutaway view of the device. Now, actually, I flipped it over. This is the bottom, as you can see here. You can see the terminal leads protruding from the top here. And in this picture, you see that this is the inside. This is upside down, actually. So this is the bottom plate. Okay, and these are the terminals that you see in the original picture. So anyway, this is what it looks like. So it's nothing but a transformer. And all transformers, right? You have, or a basic transformer, you have a primary winding, or in this case, primary coil, and a secondary coil. Okay, and so in this video, I'm going to do more than just show you what it looks like. We're going to go into AutoCAD, and we are going to I'm going to show you every single type of part that comprises this thing, that this thing is made of. And I'll give you some explanation of how these parts work together and things like that. Okay, so this is another view of the EGPU, and I'll even zoom in here. Okay, so you can see that real good. So this right here, this is called the oil. Let's see. This will be the oil chamber faceplate right here. This is where you fill this thing with oil. The oil is used for insulation and a medium through which this thing can dissipate heat, or so transfer the medium from which the heat transfers from the coil, from the internal coils, which are this right here. This is the coil assembly. So the oil will fill in this area here. So the heat goes from here and it radiates from the case of the transformer. Okay. Let's go to the next picture. Oh, and these holes right here, these are mounting holes for the eGPU system. This device here, what you're seeing, this is just the eGPU. As I said, it's a transformer. This is the source of the free energy. And basically the output of this thing will be greater than the input. That's how it's deriving the free energy, or that's why I say it's a free energy device. Okay. Okay, next picture here. So you're seeing the coil stack assembly with the bottom. See, the actual name of this is transformer case faceplate bottom. So this is the transformer case faceplate top, and this is the transformer faceplate bottom right here. And just so to give you a better picture, okay, so let's zoom in here. Okay, transformer faceplate top. This is what it looks like. Oh, and by the way, I have a Patreon page. I'm trying to raise money to build this, and once I'm able to do that, I will of course make another video showing me assembling this unit, and then I will make a video showing me testing this unit, proving to you that it does indeed output more energy than its input is. And as you can see, these are the input terminals, which are the terminals of the copper coil, and these are the output terminals, which are the terminals of the output coil. So the input coil is the primary coil, the output coil is the secondary coil. Okay, so let's proceed here. Okay, so we've seen that already. Let's go here. Okay. Again, this is another view of the coil stack assembly. Okay, and if you look closely, this is copper, which is the primary coil. This is iron or steel, which is the secondary coil. So if you watch my video titled Overunity Free Energy Transformer Full Disclosure, excuse me, if you watch that video, you will see the significance why the primary is copper and the secondary is iron. That is the whole basis of how this is able to produce more energy out than what you put in. So just to be clear, the primary coil, the primary side, that energy that goes in, you're switching the primary and you're pulling your load from the secondary. So you're putting energy in here and you're drawing energy from out there. And I'll show you some more views. Okay, these are the red silicone gaskets. And as you can see here, because this thing has to be sealed because it will be holding the oil. Here's another view of the gasket. Here again, this plate right here is called the transformer case faceplate. This is the top. Oh, that's my company name, by the way. That's my logo. And just to explain to you, this is a pyramid that has the same ratios of height, the height of the pyramid to the length of the base, as the Great Pyramid of Giza, the same angle of inclination as the Great Pyramid of Giza. And many years ago, I did some experiments to verify that these pyramid does generate energy fields. So on my company logo, this egg-shaped field is a representation of the actual egg-shaped electrostatic field that I was able to measure when I energized my pyramid that I made. And this circle represents the in 1/3 from the top of the pyramid. So this is the top going down 1/3. 1/3 of what? 1/3 of the distance from the top to the bottom. Okay. So you start at the top, you go down 1/3. This is where the energy density is greatest of the torsion field that this pyramid generates. And a torsion field, think of it as it's like a tornado, except the thing that's swirling instead of air, as like in a real tornado, the thing that's swirling are magnetic fields inside of the pyramid. So this circle represents that bubble or this area where that torsion field energy is at its greatest. And then, as I said before, the egg shape represents the external egg-shaped field that this structure generates. Okay, and Enye stands for, it's Latin for celestial fire. And over time, you will see why I picked this particular company logo and company name. All right, so this is, as you can see, this is the faceplate, the top faceplate without the terminals or anything. You can see output terminals are here. Input terminals will go here and here. All right. Oh, okay. And this material is made from phenolic. Actually, it's a G9 glass cloth woven phenolic. So the type is G9. It's and the reason why I picked this material is because of its high temperature resistance characteristics. Obviously, you have transformers, and transformers get hot, so you need materials that can withstand that heat. Now, I have to admit that the color of this material is a little misleading because G9 is actually like an ivory, an off-white color. The G10, I believe, I'm saying this off the top of my head, but the standard phenolic looks like this, but the G9 is basically one level higher than what you're seeing here. So I just wanted to clarify that. Okay, so this is the top of the top faceplate. This is the bottom of the top faceplate, or the transformer case faceplate top. Okay. Now, okay, this right here is what I call, or what is called, the copper coil terminal layer. The reason why it's called the terminal layer, because the terminal will fit right here. So this is the coil layer that the energy or the electricity will enter the coil. Okay. This is made from copper, 1/16 of an inch thick. And if you guys could so kindly subscribe and contribute to my Patreon page, on my Patreon page, I have about 50 plans, 50 technical engineering drawings that will allow you to build this for yourself, where all of this is dimensioned, every single hole, everything. You will be able to have all that information. Okay, so let's go to the next picture here. Okay, now you see the terminals, these things here. And just to give you an example of what you will get by subscribing to my Patreon page, voila. Okay, let's go here. Copper terminal top plate. Okay, so there are several versions of this, as you can see up here. Copper terminal bottom plate, As you can see, the threads are a little shorter. These are 1/4 inch 20 threads here. The copper terminal top plate, these are 3/8 16th threads, and you can see the threaded area is a little longer. We have iron terminal bottom plate here again, 3/8 16ths. The thread area here is shorter. Iron terminal top plate, 3/8 16ths, and so forth and so on. So let's go back here because, okay, these are going to be this copper terminal top plate. So this is an example of what you would get, or what you'll be able to download from my Patreon page. Actual, real, technical working blueprints that can be taken to a machine shop, and they can make this thing for you. Everything, all the information that they need is here. Now this is, as you can see, this drawing, this is 1 of 2. See down here? This is sheet 1 of 2. So it took 2 sheets for me to be able to dimension all the aspects or characteristics of this one part. This is just an example, so you can see it here. You can see this is 3/8 16ths threads right here. These set screw holes are 1/4 inch 20s, and so on. So here you can see what the internal structure of this terminal is. You can see this little hole right here, and this is where you would insert the stripped 0 gauge copper wire. You have 2 set screws to firmly secure that wire inside of this terminal, and that wire is an internal wire. This wire will come up here and connect to this coil stack assembly. Okay, these parts here, these are stages of what I call coil layer guides. Okay, and obviously you see that they're guides. They, as you are assembling this thing, these help maintain, you know, precise coil location or coil layer location, so everything will match up and stack up correctly. Okay, so this is the coil. This is where the electricity, the positive terminal basically is for the primary coil. Copper, the copper layers, all the copper layers are the primary, make up the primary coil of this eGPU transformer. Okay, so let's go to the next picture here. Okay, so let me go back, make sure I didn't miss anything. Okay, and you can see here, this is made from red silicone rubber. This is type 50A, which all this information is given in the prints that you can download from my Patreon page. And so here again, red silicone rubber has, it's very durable, it can operate, or it remains stable between -65 degrees up to several hundred degrees Fahrenheit. So it has good structural or good material stability. It's good gasket material and very good temperature, high temperature resistance characteristics. Okay, so, okay, and these are the mounting holes. So when I'm able to actually build this thing, or maybe one of you guys will be able to build it before me, okay, you're going to need some supporting electronics to actually power a house. And for example, if you go on my Patreon page, some of the supporting documents that are provided with this library of prints, I have something called the eGPU block diagram explanation and parts list. So obviously the block diagram will show you all the different aspects of the eGPU system. And so what I'm saying here is you will need things like an inverter, you'll need a switching electronics to provide the initial electricity to energize the primary coil and switch it. So it'll induce electricity into the secondary coil. And so that's what these are for. These holes are for hex nuts to go into. So when you actually build the full assembly with the inverters and all the supporting electronics, this will provide you a way to be able to attach or to affix this transformer to whatever supporting platform that will also hold all of the support electronics to be able to power a house or a car, or electric car. Okay, so let's go to the next picture. Okay, now let me go back to this picture just to be very clear. Okay, here you have your first coil layer. Okay, you have your terminal affixed, connected to the coil. So this is your positive terminal. The electricity will go in here, it'll travel around here, and it'll come out here. So this next picture, okay, this is, oops. Okay, let me zoom in here. Okay. These white parts, they're made from Teflon. Here again, Teflon has very high temperature characteristics. It can withstand temperatures up to or around and a little bit in excess of 400 degrees plus. Okay, this is an insulation layer, and this right here is actually called the Coil Air Gasket. These parts here, this here, are actually called the gasket for coil layer to layer connectors. So these part names that you are hearing me say, I'm reading it from a document that I created, which is part of the supporting paperwork that you can download from my Patreon page if you wanted the full disclosure of this free energy device. And the title of that document is called eGPU Parts List, and that's what I'm reading from. So on this parts list, it gives the name of all the parts, and also the type of material that those parts are to be fabricated from. And so under the Teflon section, that's where I'm reading these part names. So in review, this right here, this is the Coil Air Gasket. This, and this are called gasket for copper coil layer to layer connectors. Okay, let's go to the next one. Let's see. Go here. Let me zoom that out. Now I can go to, okay. So here, what you're seeing is this is the iron coil terminal layer. Okay, this is the piece of iron. Okay, this is the terminal for this iron. This will be positive output. Okay, this is positive input, positive output. Now you can see why these are slightly different in their dimensions, because as you can see here, the iron coil terminal layers are a lot thicker. These are 1/4 inch thick, whereas whereas the copper, oops, go back here. Okay, whereas the copper layers are 1/16 of an inch thick. And the reason for that is because iron has a higher resistivity than copper. So basically electricity encounters more resistance as it flows through iron relative to that of copper. So to compensate for that, when I was designing this transformer, I said, okay, I'll just make the iron layers thicker. So if I'm banging the primary with the 100 amps, I need to draw 100 amps from the iron secondary. I need to make it thicker so the thing won't, get cherry hot and burn up. I can mitigate my losses due to resistance by increasing the thickness of the iron coil layers, since iron naturally has a higher natural resistance to the flow of electricity. Okay, and guys, if what I'm saying, like the first time you hearing me say this, right, and you don't understand it, just stop the video, back it up a little bit, and listen to it again. Some of us, we may have to listen to it several times before we can understand what I'm saying. Hey, it's okay, because what I'm doing here, to my knowledge, hasn't been done before. I'm not saying it hasn't been done, but from the research that I've done for the many years into the free energy power generation world, I have never seen an inventor perform this level of public disclosure that I'm doing. And I'm doing this on purpose because, guys, I really want you to know how this works, why it works, how it's assembled. I want you to know everything. Because, some inventions that have been patented, even though, 80-90% of the inner workings and the secrets of the device has been disclosed in the patent, sometimes there's some little things that have been left out to where if you're trying to replicate the technology, you can't, because it's not there. I'm not going to do that. That's why I'm taking the time with these long videos to show you in detail how the eGPU works and its components that allow it to work the way that I say it will. Okay, so let's go to the next picture. So in review real quick, because I know I do a lot of talking. Okay, we have faceplate. This is the top faceplate. Flip it over. Oops. Okay, sorry. Okay, top faceplate. Flip it over. That's the bottom of it. Okay, coil. Copper terminal coil layer. Okay, this is the first layer of the copper coil. Terminals. Okay, these are the input terminals. These are the coil layer guides. And all of this is made, this and this, these are all made from the phenolic G9 class material. This, obviously, as you can see, is made from copper. You can see that's made from copper. Okay, Teflon insulation layer. This is 32 thousandths thick. I'm sorry, 31 thousandths thick. I can't remember how thick these gaskets for the connector are, but you can get all that information from the prints. And okay, and gasket. This is the red silicone gasket. Okay, iron terminal layer. Okay, remember, copper primary coil, iron is secondary coil. Copper primary coil, input electricity. Iron secondary coil, output electricity. Iron, you're going to draw more energy from the iron coil than what you inputted in the primary coil. And if you want to know why, watch my video titled Overunity Free Energy transformer full disclosure. Okay, let's go to the next picture. Okay, here again, you see another insulating layer of 31 thousandths of an inch thick Teflon. And you see more spacers or gaskets. I call them gaskets, but they're also spacers. Now, there's also something I want you to see. Okay, oops. Okay, check this out. Let's go back. Okay, copper coil terminal layer, gasket, iron coil layer, gasket over the iron. Now, look at this. Also, if you look closely here, this is the copper coil terminal layer. See there? You can see the terminal, copper coil. Okay. See this right here? This is called, these are called the copper coil layer to layer connectors. This right here, and that right there. So that's how this is a coil, even though it doesn't really look like a coil. Once you build the stack, this is how the electricity, the positive charge, enters here. It goes through the coil, comes out here, it goes up here, it goes up here, through here, up here, and then this is the next layer, and it comes up here, goes around, comes out here, and then it does the same thing over again. So let's zoom in here. And let's look at this closely. Okay, this is remember we're looking at two different coils here. We have the primary coil, which is the input side, which is made from copper. We have the secondary coil, which are the output side, which is made from iron. So we have actually two coil systems that are working together as a transformer. For you electrical engineers out here, yes, this is a new type of transformer. I actually invented a new configuration of the secondary and primary windings of a transformer. So we're not going to use windings, that term windings, because that is referring to taking, a very long copper magnetic coil wire and winding it around a coil form, which you have an iron core going through it. This is not that. That's why I'm saying these are coils. They're still coils because electricity is still going in a circular fashion or going around, but it's not a wire, it's a coil, and you have these layers. And I did this because this thing is rated for at least a 5 kilowatt, 5,000 watt output. I designed these coil layers to be able to conduct 100 amps all day long without burning up. That's why everything is so big. Okay, so with that being said, this is how you connect this coil layer to that coil layer. So you want to connect this to this. You use this. So let me zoom out here and let's wanna go. Okay, here are some renderings. Okay, this is a close-up. This, and this, as I said before, are called copper coil layer to layer connectors. Okay, and this is not one piece, and you'll be seeing that once we go to AutoCAD. This is not one piece. These are three separate pieces. This is a piece, this is its own piece, and this is its own piece, and you stack them. So you see how the electricity will be able to go from one coil layer to the next coil layer via these. And I designed this in this manner because this is the way you build this. It's really simple. You just stack all these parts on top of each other and you will get this. This is what it looks like. Okay. So I isolated just the coil, the copper coil layer, layer to layer connectors, so you can see what they look like. But I isolated it, and then I isolated the copper coil layers right here. Okay, and here, this is another view. Let's zoom in a little here. Okay, so this is another view of all of the copper coil layers in the stack. Okay, and okay, that's the close-up. Okay, so here, just again, I isolated these two layers along with the copper coil layer to layer connectors. So now you should have a very good understanding of how this coil system I designed works. You stack these layers, and when you stack them, you get this configuration. So electricity goes in here. Actually, let's start here. Okay, this is the top coil, copper coil terminal layer. Remember, the one we've been looking at was, okay, let me take that back. This, if you could see the plate that this is sitting on, this will be actually the transformer case face plate, the bottom one that will be right up here, that this will be sitting on. I don't want to confuse you guys. Just follow what I'm saying. Sorry. Okay. So electricity goes in here, right? The terminal will go right there, your terminal connector. Okay. Electricity goes in here, it goes around here like so, and it comes out here. This is a piece. It goes here. It goes, this is this another piece, right? Coil layer connector, coil layer to layer connector parts, right? So electricity goes in here, flows around, goes here, comes out, flows through this layer here, this connector piece, goes to this connector piece, crosses over here, goes to this connector piece, and then it goes here, flows around, comes out here, and then does the same thing over again. Okay, so that's how that works. Okay, these are the layer to layer iron connector pieces, and as you can see, these are a lot thinner than these for the copper. And the reason for that is because the iron coil layers, as you saw, are 1/4 inch thick. They're a lot thicker. So if you want all the precise measurements and all that, you can, go to my Patreon page, subscribe, and download all the prints, and you can analyze all the geometry of the parts that comprise this eGPU transformer. Okay. And then this right here, let's zoom in a little bit. These are two layers of the iron coil, right? This is layer 1, layer 2, and I'm showing you, just like the copper, the electricity will flow through the layer. It will come up here, cross over here, and bam, go to the next layer. Okay. So, and that picture was for something else. All right. Okay, so let's go back here. Okay, so in review, I'm going to do this again. Okay, top faceplate, that's the top. Bottom, copper, the copper terminal coil layer. Coil guides, the terminals, insulative 31 thousandths thick Teflon insulation material. These are the gaskets or spacers. Okay, iron layer, iron insulation, and copper. Okay, and this tube right here, this is the main, this is called the core tube. This is the core tube of the entire transformer. This too is a G9 phenolic material. As you can see, this is what keeps all the layers centered. Okay, and these terminal guides keep them from moving that way or that way. Okay, so as you can see, between this core tube and these coil layer guides, I'm able to keep all the layers of this coil layer assembly stack perfectly located, so I can get good contact between all of the layers and it'll work properly. Okay, let's go to the next picture. Okay, so what you're looking at here, between this picture and this picture, they're a picture of the same thing. Okay, you're looking at, I call this one cell of the coil layer stack assembly. And let's go here because we can see it better. The reason why I call it one cell, as I stated before, this is the iron coil layer, and it's sandwiched by the copper coil layers. Copper on bottom, copper on top. And the reason why I designed it this way, and oh, another thing is this cell, the coil stack, this right here or this right here, this one you can see it better. Okay, this stack is comprised, it's made up of 100 of these cells. Okay, so 100 of these equals this. Okay, remember, copper side, which is primary input side, iron side, secondary output side. Okay. Now, what's significant about this is in conventional transformers, the efficiency of the transformer, one of the main characteristics of that transformer that's going to determine how efficient that transformer is the ability for the primary and secondary coils or windings to be able to couple magnetically. Remember how a transformer works. You have a coil of wire, which we call the primary coil. When it's energized, it produces a magnetic field, and that magnetic field induces an electrical current into the secondary winding. Okay, so the actual way the transformer is designed, the way that the primary coil and the the primary coil and secondary coil are coupled, but basically in a conventional transformer, you wrap the secondary coil first, and then you wrap the primary coil around the secondary coil. And the secondary coil will be wrapped around your iron core. And your iron core, you can think of it as a flux line concentrator, or I like to say or think of it as a magnetic field amplifier. Okay. Because it amplifies the magnetic field within a certain volume of space. But we're not going to get too technical as to the mechanics of transformer design, because I don't want to lose people here. Trying to keep this as simple as possible. But so basically that's how a regular transformer works. In my transformer, there is no iron core because the secondary coil itself is iron. So to increase the efficiency of the primary, which is the copper coil's ability to magnetically couple with the secondary, which is the iron coil, every iron coil layer needs to be sandwiched or in between two copper coil layers. Okay, so as the electricity is flowing through these individual layers, they become, they're conducting a current, which means they're generating a magnetic field. And since it's a coil, which means all of the layers, the electricity is traveling in the same direction, those fields will add, or you have a summation of fields. And basically the flux lines of the field generated by this copper coil layer and this copper coil layer will be in attraction through this iron coil layer. So basically I did this to increase the efficiency of magnetic coupling between the copper coil layer and the iron coil layer, or this configuration makes the magnetic coupling between the primary coil and secondary coil very efficient. That was a mouthful. This is, you may have to rewind that and rewind what I just said and listen to it several times to understand what I'm showing and explaining here. So anyway, this is the essence. This is how or why my transformer is an Overunity Free Energy Transformer, because in my secondary, I'm using iron, which is a ferrous material. It is magnetic. Copper is diamagnetic. So in a conventional transformer, this wouldn't be iron, this would be copper. And just, conventional transformer is set up completely different. But anyway, this will be copper, right? And so copper is diamagnetic, and that produces the back EMF. Iron is the opposite. Iron is magnetic. Therefore, iron is magnetic. So there is no back EMF. Okay. So when this primary coil, which are these copper coil layers, when they're energized and they're conducting electricity, they're generating their magnetic fields. Their magnetic fields are not fighting the magnetic field of this iron layer as I'm putting a load on, or I'm drawing electricity from the iron layer. If this was copper, they'll be fighting, and that will cause back EMF. But this is not copper, it's iron, which is magnetic. So as you guys know, iron will not only concentrate the flux lines, but it's like a magnetic field amplifier. Okay. So without the back EMF, all that energy that was wasted in a conventional transformer, we can now extract it as electricity in this transformer because there is no back EMF. And if you want an in-depth explanation, again, of this situation of back EMF, please watch my video titled Overunity Free Energy Transformer Full Disclosure. Okay, so let's proceed. Now I'm going to run through, we're going to watch a few short video clips that I created in AutoCAD. This is just to give you a 360-degree perspective of what this, what this thing will look like as it's being assembled. Here we go. Oops. All right. Let's see. Okay. That's the top faceplate. Here is the copper coil terminal layer. Okay, you can see the core, the core tube. You can see the coil air guides. You can see the terminals here. Let's just play this one again. See the gasket. Okay. Okay, these are the Teflon layer to layer connector gaskets. You can see the insulation gasket right here. There's the iron coil layer. And as you can see the terminals for the iron. Let's go. Okay. Then there's the gasket over the iron. Okay, and it's being built up. Okay. And right here, okay, in this video, let me just back it up a little bit. Okay, let me go back. Okay, here we go. Okay, so this is just showing me putting in, just putting in more copper and iron layer to layer connector pieces. Okay. All right. All right. So we've seen this. Let's go to the next one. Okay. Put the copper layer on top of the iron. Okay. See that. And then insulate that. So now you've seen an animation of one layer of the coil stack assembly being put together. Okay. And here that is. This is the one cell of the coil stack assembly. And that should be okay. And this is just what it looks like. You know, you build it all the way up. Resolution's not so good because I have to do animation. But anyway, now you see what that's about. Okay, let's do some fun stuff and let's get into AutoCAD. We're in AutoCAD now. So this is what I'm going to be doing. I'm going to show you every part, and I have this file open. I call it right here assembled eGPU, and I have layers here, and these are all the parts. I have everything frozen or the layers turned off so you can't see the parts. So I'm going to show you the part. I'm going to turn that part on in the layer, or turn that layer on. For example, let's start with the base plate of this thing. So right here, transformer case rear faceplate. I'm going to unfreeze it. Okay, let me okay, let's see. Yeah, let's move this up here. Okay, so okay, I'm gonna freeze it. See, it disappeared. Unfreeze it. Okay. We're gonna close this. Okay. And zoom extents. There we go. Aha. You see it. Realistic. There we go. Okay. So this right here, this is called the excuse me, transformer case faceplate bottom. So I'm going to go here and rear. Okay, rear. And there's another image of it here. and we're just waiting for, okay, there we go. Now I can, so this is, I'm able to rotate this thing around so you can see its features. And remember, all of this is on my Patreon page. For those of you who subscribe to my Patreon page, you will be able to download the working blueprints, the technical drawings for these, and you will get these actual AutoCAD files. You may, you know, you may see a way to make this better. I want this out to the public. Okay, make it better. You know, I planted that idea, that seed in your mind. Make it better, please. And I hope you share. I hope you build this, and I hope you share it with others, especially if you're able to make modifications to make it better. Okay, so anyway, here we go. This is for the oil cap. This is where you'll pour the oil in once this thing is fully assembled. And here, since this is not a metal, I don't like threading plastics. And when I'm, you know, designing things for fabrication, I think it's stronger and easier and cheaper if you just, like, as you can see, let me zoom in here. I have these indentions. A hex nut will fit in there. I can't remember what size bolt that's for, but hex, I think it's number 10, maybe, I'm not sure. But anyway, the hex nut will fit in there. Okay, and so when you screw this thing together, excuse me, you can, you know, put a little silicone glue in there, glue the hex nut there, and then when you put this lid on and you bolt it, the bolt will screw into that nut. Okay, these are for the rear terminals, and that's basically it for this thing. So, okay, let's go back to the assembled thing, and that's this right here. So now let's go to the next part. We're going to go to look at the core tube, and that will be phenolic core tube, and there's really not much to see there. It's a tube, guys. You know, you can look around it and all that. Nice little tube. Okay, so let's go back to the assembled page here, and I'm going to go to my layers, and let's unfreeze. Okay, phenolic. Let me find it real quick here. Transformer case, plate, front, back. Oh, come on. Okay, phenolic tube right here. Unfreeze that. Voila. There you go. So that's how that tube fits in there. Let's do that so you can see. Okay, that's how that looks. Okay. Now let's go to this right here. Transformer case front plate. And here you go. You have your output and you have your input right here. Output, input. Okay. And let's spin this thing around. And sorry, yeah. Okay, there we go. Computer was freezing up a little bit there. Okay, you can see where the phenolic, where the coil air guides will fit into here and here. You see where the terminals will fit into. You see where the core tube will fit into. You see where the gasket, the red silicone rubber gasket will fit into. See all that? Now let's do something here. Let's do something pretty cool. Let's change this to an X-ray. Oh, come on. Okay, let's change this to an X-ray. Okay, so this gives you just a more in-depth perspective as to what this thing looks like. Let me hit that. And there you go. Okay, so you can see the counter bores here for the 1/4 inch 20 socket head bolts that will bolt this whole assembly together. And okay, so let's go here. Now let me activate the layer. Okay, Teflon front. Okay, transformer case front faceplate. Let's turn that on. Voila, there you go. Okay, there you go. So you're seeing the parts and how they fit together. Okay, let's keep going. Let's go to the Coil Air Guards. Okay, as you can see here, these are the phenolic guides. Make 6. Okay, so you have a 6-inch, and you have a 3.5 and some change inch long, and then this is a connector that will go into. You can see there's holes here, so that will go down into there, and then that, as you can see the bottom here. You see the bottom right here. Okay. So that will go into there. And that's how you are able to stack those. Now the reason why, okay, the reason why I designed those in that manner is, as I said before, this thing is around 3.5 feet tall. So as you're stacking these coil layers, you know, you don't want, you want these things short, so it won't be so hard. You don't want to have to slide all the way up from up here all the way down like that. So that's how you do it. So anyway, let me turn this on. Let's go here. Phenolic guides. Let's activate the video one. Let's see which one. Okay. Let's go here. Okay, there we are. Okay, here you go. Here are the guides. Just waiting for my computer to catch up. Hurry up, computer. Okay, here we go. Go up here. Here we go, right there. Okay, here are the guides. Right here. So I mean, the guides actually go all the way up into here, but I just wanted to give an example. Like, as you're stacking these coils, these are made up of those 6-inch and 3.5-inch segments. So you start here with like 6 inches, you stack. Once you get to the 6-inch, then you can put another layer of coil guides to give you another 3.5 inches. Stack, and you just I'm sorry, 6-inch. It's 6-inch stack. Let's go here. Okay. So as you can see here, these are phenolic guides. Make 6 of the 6-inch and 1 of the 5, 6, 5, and 6-inch. Okay, I had to modify this. Okay, so they edit this part out. All right, so that's how this part works. Okay. So as you can see, that's okay. So now let's open. Let's start with a copper coil terminal layer. Let's unfreeze that. There we go. Copper coil terminal layer. And that's what that is. And that's pretty self-explanatory. We've already talked about that. And computer is going slow. And here we go. You see what that looks like. Okay. Let's go back here. And I can zoom in here. There we go. That's how that fits. Okay, let's go to, what I'm gonna do here is let's move this. Let's change our view here. I'm gonna move this over down here. Let's change our view. Oh, come on. Okay. There. Okay. So as you can see, this is the top faceplate, and I'm flipping it over so you can see the bottom of it. And what I'm going to do here is I'm going to go down and we're going to turn on the copper coil layer connector. Let's turn that on. Copper coil layer. We turn that on. Unable to modify layers while another command is active. Okay. So it doesn't, here, there. Doesn't want that. It doesn't, AutoCAD doesn't like the orbital command active. So let's go here and turn that on. Okay, let's go here and turn that on. Okay, there we go. Okay, let me turn it off. Okay, I'm gonna go here and zoom in. Okay, I had to zoom in so you could really see it. And so I'm gonna go here, copper coil layer connector. So when I turn that on, okay, see that right there? Okay, see that? Here, let me highlight that. Okay, when I turn it off, okay, turn it back on. Okay, that way you can see. I just did all that so you can see how this thing goes together. So let's add another. Remember I was saying there's 3 of those copper coil layer to layer connectors. So let's go to the second one. Okay, see number 2. Let me turn it off. Okay, turn it back on. Okay, let's go to the next one. Number 3. Okay. See what's number 4 about. Okay, let's keep number 4 on. All right. So you just saw me build that real quick to show you how these individual coil layers are connected. So what I'm going to do here, let's go back to view. Let's get this navigation bar back on. And let's go 3D here. So we're back here, and okay, so we've already looked at the copper coil terminal layer. Let's go to the copper coil layer to layer connector parts here. And let's close this. Okay. So here are the parts. Remember I said there's 3 parts. Here they are right here. And here again, just to really show you how they fit together. Let's go here. We can just stick it here. This here. And okay. So I'm gonna move just like that here. Like that. Okay, so I just assembled these 3 copper coil layer to layer connectors, and you saw me assemble them, so you should recognize that. All right, and this is just to make sure there's a firm understanding of how this machine is put together. So I'm going to undo all of that. There we go. Let's go to the next one. Copper coil layer. Okay, so just to show you the difference, copper terminal coil layer. Okay, see that? And I'm waiting for the mouse to catch up. See this area right here? Okay. When you go to the copper coil layer, okay, that's how it's different. So there's only 2 of the copper coil terminal layers. Okay, there's only 2, and you can see this one here and that one there. Okay, there's only 2. Let's go here and move this so we can, all right, there you go. You can see that better. And sorry guys, computer's a little slow. All right, there we go. All right, that one on the bottom plate. And yeah, AutoCAD is a pretty powerful program. And so my computer is a little older, and this is what I have to work with, so that's why it's taking so long. And hurry up, come on. Okay, let's go up here and speed it up a little bit. Turn that on, turn that off. All right. Okay, there we go. And that's the other terminal layer. Okay, so get that. Let's reset the view of this thing. Get this. Okay, there we go. Now, the rest of these, I'm going to go ahead and, okay, before I turn those on, let's go down to the iron coil layer connector parts. As you can see, I have a lighter color background so you can see it. And these are the same as the copper, but as you can see, they're a lot thinner. You can go to my Patreon page and subscribe and download the prints if you want all the exact measurements, if you want to build this. Okay, so that was the iron coil layer to layer connector. Here is an iron coil layer. Wait for the mouse to catch up. There we go. Okay, that's what it looks like. Same thing as the copper, except it's thicker, 4 times thicker than copper. This is 1/4 inch, copper is 1/16 thick. Now, another thing to note, and you will see this in the prints, this ID right here is a little larger than the copper coil layer. And I did that, excuse me, and I did that to make sure that I get optimum insulation characteristics to insulate the copper from the copper layers from the iron layers. Okay. Let's go down here. Okay, so okay, iron terminal layer. You see what that looks like. Same thing as the copper, it's just thicker. And orbit that around. There we go. Okay. And red silicone rubber faceplate gasket. Okay, and you recognize this gasket. Okay, so we're going to go down here to the assembled, and let's turn on those gaskets so you can see where they fit. So I'm going to zoom in right here. Let's close that out for now. Go here. Zoom in here. There we go. And let's move this up a little bit here. Now let's find the red silicone rubber gasket. Red silicone, there we go. Okay, red silicone rubber transformer case gasket. Turn that on. Oh, oops, okay, now let's try this again. Okay, turn that on, and voila, there you go. You have one here, and you also have one on the top plate. So this gasket, when we put the case on this thing, what happens is, let's close this out. This gasket creates a seal between the case and the bottom and top plates. So I'm going to go ahead and activate the case so you can see. Okay, transformer case. Let's turn the case on. Okay, there we go. So here's the case. Zoom in a little bit. Okay. And that's the lip of the case. And the screw holes here, as you can see, these bolt holes, the bolts will go through here. They're counter to the counter bores. These are the counter bores right here, as you can see. See, it's counter board. Okay, so the bolts go through there, and you have internal threads in the lip of this case. And so the bolts go through here and they screw into here. And so that case here, let me turn this off. Okay, sorry about that. Okay. The case here, take the case. So this gasket creates a seal between the case and the faceplates. Okay. So that's what that's about. And yeah, there's a lot of parts, but you know, that's what this thing's made out of. Okay, so let's go to oil faceplate gasket. Okay, the oil faceplate gasket, this is what it looks like. All right. And that's pretty self-explanatory. And now I'm going to show you where this fits on the machine. Okay. All right. So here's my mouse. Come on, mouse. Okay, there we go. So I'm gonna zoom out. We're going to flip this. Let's move this down here. Oh, okay. Sorry, we don't need to flip. We flipped it the wrong way. Okay, flip it this way. Okay, give it a little time. All right, there we go. Oops. Okay. Right here. Sorry. Okay, that's what I was trying to do. Okay, so we're looking at the bottom faceplate. Okay, right here, this is where the oil cover goes, and the oil cover gasket goes right here, and that just creates a seal so oil won't leak out of the eGPU. So let's go here and let's get these layers back, and let's turn on the okay, oil cover gasket. Turn it on. There you go. You can see it right there. Let me turn it off again. Went away, turn it back on. Okay. So that's where that fits. Close this right here. Okay. Let's go to Teflon layer gaskets. Okay. This is 31 thousandths of an inch thick, and this is nothing but a ring of Teflon. And this insulates the copper coil layers, excuse me, sorry guys, copper coil layers from the iron coil layers electrically. So that will eliminate any shorting between the iron and copper coil layers. This is really simple. And that's all that is. Okay, I'm not going to turn those on in the assembly yet. Let's go to the next one. Let's see. Teflon gasket, copper. Okay. This is the Teflon gasket for the copper coil layer to layer connectors. They provide insulation and spacing, and you're going to see that real soon. That's how they fit into the machine. We're going to go through this pretty quick. Okay. So let's look at the terminals. Okay, this is the copper terminal for the bottom plate right here. And pretty self-explanatory. Now, so the way this is designed, this hole right here, this is for a stripped 0 gauge copper wire. So that wire will fit in here, and then you have 2 set screws right here that will secure that wire in this terminal. So the way these terminals will look in the assembled unit, I'm going to go ahead and turn those bottom terminals on here. Get that centered where you can see them. Okay, come on, AutoCAD. All right, computer froze up here. Get the computer freeze. There we go. Okay. So I'm going to go in my layers and let's turn on the terminal. Okay, copper terminal right here. Oops. No. Okay, let me. Yeah, it's a little frustrating. I have to, you know, there are a lot of parts and I have to find. Dang it. Okay. Here we go, right here. Terminal. Okay, this is the rear faceplate. So let's go here. Faceplate, turn it on. There we go. Okay, there it is right there. There it is. Okay. And let's flip this. Okay, come on. Okay, let's go here. Let's flip this over. And there, you can see. Okay, you can see where it protrudes here, and obviously a nut will screw over that. Okay, the whole purpose of this terminal, no wire, like as you can see the counterbore here, this isn't to hook a wire to or connect a wire, okay? This is simply to connect this terminal to this copper coil terminal layer. This is the bottom. When we go to the top here, and I'm going to go ahead and turn on the other coils. I mean, I'm sorry, the other terminals here. Okay, let's turn those on so you can see exactly what and I'm sorry this is taking a while, guys, but I mean, it takes as long as it takes. You know, we have to just be patient, and right now we're learning how this machine is put together. We're learning its components and how they fit together for operation. Okay, so this is the faceplate front, copper for the copper layer, which is the input. Turn that on. There you go. You can see that one. And let me go over here so you can see both of them. Okay, there we go. There's both of them right there. That one and that one. Okay, let's go ahead and turn on the, okay, yeah, sorry, I forgot about that. Let's go ahead and turn on the iron one. Faceplate front iron terminal. This is for the iron coil. It's not, that's a little misleading because all of these terminals are made from copper. Copper has very good conductivity, low resistance for the flow of electricity. Even though the coil is made from iron, I did not make the connector terminals from iron. That will be from copper. Okay, turn that on right there. All right, anyway, so the way this works, these terminals are what connect your power input and power output to the actual physical copper and iron coils. Remember, the copper coils are the primary and the iron coil is the secondary. Okay, so the way this works is, this is your positive, this is your negative, right? Hook that in there. Now, if you're using an AC power source to drive it, yeah, it don't matter. I'm just doing that just to give you perspective for explanation purposes, okay? You're not going to run this thing on DC current, okay? So flip it over, and actually I got that, okay? So this goes in here. This energizes this coil, and what we'll do is we'll go ahead and turn on, we're going to go ahead and turn on all of the copper coil layers. Copper coil layer, turn that on. All right, there we go. So let me turn these off. Okay, where I left off. Okay, so you see the terminals. I'm going to go ahead and turn on the copper coil layers. okay, in its entirety. Let's turn everything on. Make sure all of them are on. Yeah, all of them are on now. Okay, so here we go. So what you're seeing here is I've turned on all of the copper coil layers. This is not the coil layer stack assembly in its entirety. This is just the primary side, as you can see here. Okay, just the primary side. And I did this because I want to show you how why these terminals are here in the bottom of the bottom of the device. Okay, so I have okay, so let's just bear with me, guys. Just you know, I'm not a professional speech giver, so here we go. Okay, here is you see right here, it says input. Okay, right here, input. This terminal is connected to the copper coil terminal layer right here. Okay, and from the sample, as a matter of fact, let me turn all of the layer to layer connectors on. Copper coil layer connector, let me turn all of them on. Okay, all of the, so this is now a true coil that you can see. So I have turned on all of the copper terminal coil layers, which is this right here, and the one on the bottom plate. This is the top plate, and then let's see, this is the bottom plate. Okay, and I have turned on the all of the copper coil layers and all of the copper coil layer to layer connectors. So we have a true copper coil, which is the primary coil of this transformer, which is the input coil of this transformer. So this is how it works. This is my we're going to call this the positive terminal. Now, obviously, you don't drive a transformer with a DC current. Now, you can use a DC pulse on an oscilloscope. It'll be a DC square wave, which I plan on doing. Okay, so we're going to call this the positive terminal. Okay, so the electricity comes in here, and it let's see, let me get closer so you can really see this. Electricity comes in here, where this is connected to here, okay? And it circulates throughout this entire coil via the layer to layer coil connectors right here, like what you're seeing right here, okay? So what happens is it's going to circulate, and when it gets to the bottom of the coil, okay, that's where this the second copper coil terminal layer is right here. Let me zoom in a little more. Okay, so this is the bottom of the coil. Okay, so this will be the negative side of the coil, right? Well, that's why these terminals are designed like this, because this is where the zero gauge copper wire goes into, and zero gauge can handle 100 amps, by the way. That's why I'm using such a large gauge of wire. Okay, so this is where the zero gauge wire will be inserted, the stripped wire will be inserted. This is where the two set screws are to secure that wire. And I have to bring that wire, will have to go all the way up. That wire will have to go all the way up to, this is the bottom plate, face plate. It had to go all the way up to the top face plate here, right? So that wire goes all the way up here. And therefore, that will give me the ability to easily positive, negative. Okay, positive here. Let me make sure y'all see this. Okay, right here, positive, right? And then right here, negative. Okay, this is the beginning of the coil. This is the end of the coil. And so that wire came all the way up here and connected into the bottom of this to allow me to be able to create a circuit, you know, to energize this copper coil. So that's how these terminals work. Okay. So I've basically shown you all of the major, I've shown you basically everything, all of the parts in this eGPU. So what I'm going to do here, we'll let the computer catch up here. Hold on, let it catch up. Come on. Okay, there we go. All right. So let's zoom out. Let's go in here, and I want to make sure we understand this terminal here. So the purpose, remember, this is that terminal that goes into the bottom faceplate right here. Okay. So the purpose of this terminal is, all it is, its purpose is to connect that wire from the terminal layer here to the output terminal, or I'm sorry, the input terminal here, right here. That's all it does. That's all. That's its purpose. So that's why I have these counter bores here, because this is designed not, you don't hook anything to this. This is all mechanical to attach this terminal to this coil terminal layer right here. Okay, that's all that's about right there. Okay, same thing on the iron side. Okay, same thing on the iron side. Okay, so let's go ahead and turn on, we've turned on the copper coil. So this is what the copper coil looks like. So what I'm going to do is we're going to go ahead and turn that off. Excuse me. Before we turn that off, let me go ahead and turn on the Teflon insulation gaskets. Excuse me. Okay, Teflon Coil Air Gasket. Let's go ahead and turn that on. Okay, there we go. So you can see the insulation, electrical insulation layers right there. See that? Okay, now we're going to go in here and we're going to turn on the Teflon. Okay, we just turned on the Teflon coil layer gasket, and we're going to go ahead and turn these other ones on. Okay, now we're going to turn on the Teflon copper coil layer to layer connector gaskets. And let me, okay, there we go. So turn that on. There you go. So let's close this out. Okay, so I just turned on the Teflon. Okay, here it is, right here. We just turned on the Teflon coil layer to layer gaskets, and you can see them right here. See that? Okay. See that right there? Okay, so that right there, That's an actual copper metal connector. And then right here is the Teflon. So this is serving as one, electrical insulation, and two, as a physical spacer. Because remember, let me move this around here. Okay, let's get right here. And let's get right here. Okay, remember, I have these coil layer guides. See these guides right here? Let me rotate this around. Okay, I have right here, these coil layer guides. I have as you can see, the core tube right here. And so the way that you assemble this thing is simple. You just stack all the layers. And so these coil layer guides maintain perfect location alignment, so the stacks will align in this configuration, which will form this coil. Okay, and so you have to have these Teflon spacers in here, because when you screw this thing together, remember, you got all these bolt holes here. Look in this silicone gasket right here. See all these bolt holes? You have this case. So the way this thing works is you'll build a stack, then you drop the case on top of the stack, and then you drop the top plate on top of the case. So I'm gonna do that real quick. I just want to make sure you guys see this. So in review, you build this transformer by simply stacking all of these layers. And when you stack them all together, you get this coil. You get a copper coil, which is the primary, and you get an iron coil, which is the secondary. Primary input, secondary output. You can see here the little, little channel here where you flip this thing over and fill it up with oil. You see all that. And, excuse me. And so you see all that. Okay. And here, I just want to emphasize again, because I want to make sure we have an understanding. Okay. Follow my cursor. This right here, these are called the Teflon layer, the copper coil Teflon layer to layer gaskets. They serve two purposes: electrical insulation and their spacers. So when you stack this thing up, it will look like this. It will form this configuration, and you will have an actual coil like you see here. Okay. All right. So what I'm going to do now is we're going to let's see. What I'm going to do now is I'm going to go ahead and I'm going to turn the copper coil layers off, because I want you to be able to, I'm going to turn the copper coil layers off, and I'm going to turn the iron coil layers on. And I'm doing this because I want you to see the difference. Okay. So what I'm going to do here is let's rotate this thing so you can have a side view here. Let's do a side view like that. Okay. And then let's move it up a little bit like this. Okay. Looking good. Let's go here and copper coil layer, turn that off. Turn that off. Copper coil layer connector, turn that off. Oh, yeah, copper coil layer connector, turn copper coil layers connector, turn all these off. Okay, copper terminal layers. Let's turn those off. We're going to leave the terminal there. So all you have left here, let's go and turn we're going to leave the Teflon coil layer insulators. These here, we're going to leave those on because those the iron needs those too. We're going to go ahead and turn the Teflon layer connector gaskets, layer to layer connector gaskets off. There we go. Okay. So now we just have the Teflon insulation layer or gaskets. Okay. And you know, gaskets kind of misleading, but that's what I came up with. That's what I'm calling it. So what I'm going to do here, let's go and turn on the iron coil layer. So iron coil layer, turn that on. Iron coil layer connector, so let's turn that on. Turn all the different ones on. Just let it catch up. Iron coil terminal layers, turn that on. Iron coil terminal layer spacer, we're going to turn that on. And let's go to the Teflon. Okay, so you got the Teflon iron coil layer connector gaskets. We're going to turn, these are the layer to layer connector gaskets. These are spacers as well. Turn all these on. Okay. So now, as you can see, these are much thicker. And basically, it's the same thing as the copper. You know, just the iron side here. And I do need to, let me go ahead and turn, see right here? Let me go ahead and turn that terminal on. I gotta find it. So let's see, faceplate. Let's see, back. Okay, terminal iron. Let's turn that on. Let's see what happens. There we go. That turns on. Okay. And I am surprised because one of these terminals came up missing. Do a little investigation. I might have erased it on accident. Oh, there it is. Okay, right there. There it is. So we have both terminals. These are the output terminals where you're drawing the load from. On the iron side, remember the iron coil side is the secondary side, output. Okay, so we'll go over this real quick. So you're drawing your load from here. See right here? It's connected to the iron coil terminal layer, right? Okay. And the bottom of that coil is here. Okay, so that's the bottom, or that's the end of this coil. 0 gauge copper wire. Let's go in here and okay. Zero gauge copper wire goes in there. Set screws, you got 2 set screws, right? 2 set screws secure that. And this is the spacer I was talking about right here. As you can see, okay, and that wire will zoom out, will bring the end of this coil up here, let's get this over here. Okay, there we go. It'll bring the bottom of the coil up to this terminal. So let's go so you can see the bottom of it. Come on, AutoCAD, let's hurry up. Okay, so right here, okay, it'll come up here. So this will allow you to hook your load right here to these terminals. So this is pretty simple, okay? Yes, there's a lot of repetition, there's a lot of parts, but we're actually building a transformer winding by winding, or in this case, layer by layer, okay? That's why, you know, that's why it may seem a little daunting, but you know, at the end of the day, like I said many times, this ain't nothing but a glorified transformer, okay? A transformer where the output is greater than the input. And here again, if you want an in-depth explanation as to why that is, why the output of this transformer generates, you can pull more energy out of it than the energy inputted into the transformer, please watch my video titled Overunity Free Energy Transformer, Full Disclosure. Okay, so I really hope that this video has been informative for everyone. And I'm going to go here, and now we're going to activate everything. We're turning the whole thing on. We're building this thing all the way out, by the way. So anyway, I hope this has been informative and has brought some clarity to how this free energy transformer works and how it is assembled. Well, not actually how it works, but yeah, a little how it works, because you can actually see the coil layers, how they are constructed. And let me okay, yeah, it's kind of hard for me to walk and chew bubble gum, so let me concentrate and turn this on here. Let me see. Okay, there. Okay, so we have it. Okay, so the coil layer stack assembly is fully activated here. Oh, okay. I'm missing, see right here, I'm missing the Teflon copper coil layer to layer connector gaskets. So let me turn that on. All right, sorry, here, AutoCAD doesn't like it. Okay, now let me go here and turn that on. Okay, so now all that is on. Okay, there we go. See, we have those. So now we have our copper primary side, iron secondary side. I'm just reviewing that again. Here we go. Turning it around. Now you see it. You see it in all its glory here. Okay. And this is, you're looking at the eGPU. This is it. Okay. And so the only other thing that I need to turn on will be the case, transformer case right there. Turn that on. Voila. So this is it. Let's change the background here so you can really see this thing. Okay, we're going to go from a black background to a white background. And there we go. There we go, right there. Now you can see it. And this is the eGPU. Okay, there we go. Okay, guys, thank you for your time. Sorry the video took so long, but you know, it takes as long as it takes when we're trying to get an understanding. I really hope you enjoyed this video. Please, if you're interested in bringing free energy to the world, please go to my Patreon page and subscribe. Those donations are what I'm counting on to be able to raise the funds to build this. And like I said, I will build it on camera. I'll make a video of me building it, and I will test it on camera. I'll make a video of me testing it to prove to you guys, hey, this is the real deal. What I have here is the real deal. I'm telling you, this is a free energy transformer. Okay, this will work. And here again, refer to my video Overunity Free Energy Transformer, full disclosure, on my YouTube channel, which is my full name, Kwaku Oweridu. And that's where you'll be able to find that video. And yeah, so as soon as I'm able to raise enough funds to build this and test it and prove to everybody that it works, then the next step will be producing kits. So all the parts that you see here, I'll produce those kits, and I will offer the option of buying the kit and assembling it yourself. And you will have the video of me assembling it as your instruction manual or your reference, or I will assemble it for you and you can buy it assembled. Obviously that will be more expensive, but if we're trying to save money, you know, we can just buy the kit and you know, one could assemble it themselves. So in effort of me trying to raise money via my Patreon page, you can download all of, I have about 50 of these prints. Okay, all aspects, every part of this machine is printed out. You will receive the actual Autocad files. So let's go back to Autocad here. Okay, these are the actual Autocad files, like copper coil layer. You actually receive this Autocad file, and you could do whatever you want with it. You know, if you feel that you can change it and make it better, change it and make it better. If you want to share, and you know, share it with me, and I can share it with all of those in my following. This is a grassroots movement here. This is a grassroots effort. I am honestly trying to bring free energy to the world, but we're starting with we the people, us Americans. Okay. So that is it. Thank you for your time, and you guys have a great rest of your day or evening or morning, whatever time that you're watching this video, and please stay tuned till the next video. Thank you.